Okay, guys, so let's talk about sets in Python. So sets are well-defined mathematical objects, and we'll see how they can be used in Python. So, so in mathematics, let's quickly go through some of the properties of sets in Python in mathematics. So, um, there are some properties. So a set is just a collection of objects, and in Python, these objects can be of different types in particular. But obviously, when we're doing sets in mathematics, we typically stick to numbers. But in Python, we'll see that other objects are allowed. There's some basic properties of sets that are incorporated in Python, and they're very useful when it comes to writing programs and solving some algorithms. So, for example, there cannot be any repetition of elements in a set. So this set is the same as this, right? And there's no order to the elements. In other words, so no matter what the order, the set is the same. 1, 2, 3 is the same as 3, 2, 1. In other words, and a set can be empty also. Just like a list, and it's if it's an empty set, we typically represent it by empty curly braces. So a set is an iterable quantity or object in Python. So if you want to define a set, you can do it with the set function. So set, and then you write parentheses, and then anything iterable in that parentheses. So iterable again means it can be a string or list. So if you write ABC, Python is going to convert that into a formal set, right? Similar to what if you type in a list over here, it's going to convert it into a list. So the idea is the same. Or you can use curly braces directly instead of using the set function. Just define your own set instead of using the set function. So, as I said, in Python, Python allows any type of object in a set. So this is a string. These two are numbers, an integer and a real number, and this is a Boolean, right? So that's something interesting that you can do in Python. Now, again, as we saw that there's no repetition in a set. So if you define your set this way, so you can see with the repetition, Python is going to get rid of the repetition. So this, when you type this in Python, you'll see that it becomes this without any repetition. Now, the null set is also there in Python. So if you just define a set with empty parentheses, you get a null set or an empty set. Here is an example of a set, 1, 2, 3, 4, simple example. This example shows you that there is no repetition, so this is reduced to 1, 2. So this is very useful so if you have, let's say, a list and you want to get rid of a repetition, I do this all the time, convert it into a set, and then Python get rid of the repetition, and then you convert it back into a list. So very common way I use to get rid of repeating elements in a list also. So this just shows that it can be of different types. You can see there's a tuple over here. It can be a list also, and so on. And there is no order if you write ABCD or ACBD. There is the same thing in Python. There's no order to the elements of a set. So in other words, if you subtract a set ABCD and ACBD, you get an empty set because they're the same thing. So let's look at some functions that you can use. We've seen that. So this len function can be used with sets also. We've seen that you can use it with lists. So if you do that, you get the length or the number of elements in a set. And you can use the in function. We have used the in function now. So you can use this to check whether an element is there in a set or not. And you can also iterate over the elements of a set using the for loop. Now, this is just an example of what we saw. So this set has a length of 6. So if you use the len function, you get 6, and then you can check whether A is in the set. That's true. Z is not in the set, so you get false, and you can iterate over and print the elements of a set using a for loop. Now, there are some other basic properties of sets that are built into Python, and they were useful to implement certain algorithms. So let's say you have two sets, set A and set B, and then you want to take the intersection of the two sets, right? Now, what does intersection mean? Intersection mean that you'll get the common elements, so C, D, right? And this this picture shows you. So the common elements are going to be returned by Python. So that's the order doesn't matter, right, in this case. And you can use you can also do the union of a set. So you can use the symbol, the pipe symbol, to do the union of a set. And the union is just, it's going to combine everything again without repetition. So all of the elements are combined, as you can see from the diagram. So you get the whole the combination of the elements of the two sets, and again it's commutative. The order doesn't matter in this case also. Subtraction, in this case, so there's a difference. So there are two ways you can find the difference of two sets, and we'll see. So the first way is using the minus sign, right, the usual way. And but there is a particular thing that sets do when you do the difference of two sets. It only returns the elements. So let me say it this way: the elements that are common and that belong to the other set, they're excluded. So these are going to be excluded from the difference. Only the uncommon element of the first set are included in the difference. So you can see that AB are the uncommon elements, and AB don't belong to the set B also. So all of these, right, you get rid of, and you're left with only A and B. And when you do B minus A, in this case order matters. E, F, it's going to return E and F only, right? Because whatever comes first wins. The elements of that set are going to remain, and the common and the elements of the second set are removed. Okay, so there's another difference called the symmetric difference. The symmetric difference, the only difference from the previous case is that the elements of the second set are also kept in the difference. So in the previous case, we did not get this, right? This was excluded, but in this case, this is going to be included in the difference. So AB, right? So only, in other words, only the common elements are getting rid of. So AB and EF are going to be, and we use this caret sign for this difference. Okay, so these were sets in Python. Oh, there's one more, right? Okay. One more thing is that you can, well, no, I have two more slides, right? So one more thing you can do is that you can check whether a set is a subset of another one. You can use the less than equal to sign for that, right? And so, so this, you can see that the small set ABC is a subset, right? ABC is over here. So ABC is a subset of ABC, ED, DEF, right? So, so you get true over here, true over here. So big set is a superset. You can use the greater than equal to sign for that. And also, you can also check whether, so now since the small set is a subset, not a superset, you get a false over here, right? And since the small set, any set, if you use this, because of any set is the super of itself, so you get a true over here also. Okay. And one last thing is how to use some methods with sets. So you can add an element the way you can, so this is similar to lists, right? You can add an element to a set. You can clear up the set, get rid of all of the elements. You can also remove. So there are two ways to remove elements from a set. So you can use .remove or .discard. .discard. So if the element is not in the set, remove is going to give you an error, right? Discard is going to remove the element, but it doesn't care if it's in there or not, right? So it just doesn't care. And the .copy method we've seen creates a shallow or an independent copy of the set. Okay, so that was it for sets. Now we're done, right? And you can go ahead and work on the worksheet and let me know if you have any questions.